Sir, Zaira sir, sir, Zaira sir, Zaira sir, Jairaj sir, இல்ல இருங்க Jairaj sir, Jairaj sir, hello sir, Jairaj sir. Jairaj sir, sir.
Yes, ma'am. Yes, ma'am.
Sir, you just give stop presenting.
Yeah.
We'll be giving few things. After that, you can.
Yes, ma'am. Yes,
yeah. இதுக்கு என்னமா குத்தி நம்ம சொல்லிக்கலாமா ஸ்டாப் பண்ணிட்டாங்க. Let us start the FDP with the virtual prayer. Good afternoon to all. I am grateful to welcome you all for the 5 days online national level faculty development program on artificial intelligence and cloud services. Let us start the FDP with a virtual prayer. Let us now I request Dr. N. Swamati, Head Department of Information Technology, Sri Ramakrishna College of Arts and Science, to welcome the gathering.
Thank you, ma'am. Good afternoon, all. Respected resource persons of today's FDP, directors, heads, deans, industry experts, academicians, faculty members from our college and various colleges. I take this opportunity to welcome you all and to extend a word of welcome to everyone joined in this 5 days FDP on artificial intelligence and cloud services. At this juncture, first I thank our management and also our principal and secretary Dr. B.L. Shivakumar for permitting us to organize this FDP. And it's my privilege to welcome our resource persons. First, Dr. G. Jayaraj, Professor and Head, Department of Computer Science, Pondicherry Engineering College, Pondicherry, who is going to enlighten us today on security issues in cloud. Welcome you, sir. I'm happy to welcome our Day 2 resource person, Dr. S. Ramkumar, Associate Professor in Business Analytics Department, Christ University, Bangalore. His talk covers learning process of neural networks. Welcome you, sir. And I extend a warm welcome to our third day resource person, Dr. Ajit Singh, Assistant Professor, Department of Computer Science, Southeast Manipur College, Manipur. He will elaborate on NLP and cloud computing. Welcome you, sir. A warm welcome to Day 4 resource person, Mr. D. Sai Natarajan, President, Duratex Solutions, Coimbatore. He'll be delivering a lecture on reinforcement learning. Last, I welcome Dr. P. Shanmugavadi ma'am, Professor, Department of Computer Science and Computer Applications, Gandhigram Rural Institute, Dindigul. Ma'am has expertise in convolutional neural networks. My heartiest welcome to academicians, industry experts, faculty members from various colleges, deans, heads, and my fellow colleagues of SRCAS. We assure you that this FDP will lead to a new transformation. A small intro about our department and college. Department of Computer Science was established in the year 1987 with BSc Computer Science. Now it has grown up and offering MSc Computer Science, PG Diploma in Cybersecurity, and research programs. This department is integrated with IBM. The Department of Information Technology was established in the year 2007. The department offers BSc IT, MSc IT, and PG Diploma in Advanced Computing along with the research. The department provides real-time technical education in the field of computer science, imparting practical knowledge with industry exposure. IT department is integrated with the multimedia industry. We are happy to share that our departments are recognized under DBT Star College scheme, and our college is accredited with A plus grade by now in the fourth cycle. With this note, once again, I extend a very warm welcome to everyone joined in this FDP. Happy learning. Thank you.
Now it's the time to introduce our chief guest and today's speaker. Professor Z. Zayaras is currently heading the Department of Computer Science and Engineering, Puducherry Technological University. He has more than 3 decades of teaching experience and 2 decades of research experience. He has been editor and reviewer of several reputed journals. He has published more than 100 research papers in reputed journals and conferences. His research interests include information security and software engineering and architecture. He is currently managing the development of several software projects related to the state of Puducherry, India. He is a very busy man. Even in his busy schedule, he accepts our invitation, and today he is going to share his knowledge in the field of AI cloud services. I request Zaira sir to continue the session.
Okay, thank you, ma'am.
Thank you, sir.
I hope I am audible. Am I audible?
Yes, sir. Yes,
Yeah,
sir.
okay, okay.
Yes, sir.
Yeah, fine. I will try to present. Tell me if my screen is visible. Is my screen visible, ma'am?
Yes, sir. It's visible.
Okay. Okay. See, Yeah. So good afternoon, everybody. Thanks for the nice introduction. I'm very happy to be part of this program. And I also read the scheme today morning. Okay, so I understand the objective. They want to improve the teaching standards. That's why we are here. I really work on information security, and I'm also using cloud most of my software development. And at present, we have done some work on cloud security also. So we have used blockchain to address the security issues in cloud. So two major works we have done very recently. And I'll also be discussing, since you're all teachers, uh, I'll be discussing that work also. From there, if you're interested, you can refer my paper, and then you can also start working. Yes, today blockchain is the most hot topic, and it fits very well. To address the security issues of cloud, it fits very well. Now, let me start with a small case study. See, actually, the topic is, I think, AI and cloud services. That's a very nice topic. Actually, the need of the hour, I would say. See, I will tell you an application wherein clouds and AI services are going to contribute more. It will be really a hot topic to deal with. See, in India, I'll start off, as I told you, I'll start off with a small case study. So in India, in the banking space and financial space is actually at the moment, it is propelling the growth of the economy. So it's really doing well. So in India, all the banks are really doing well. You take any private sector bank for that matter or public sector bank, both the banks are doing very well. One is the thing, if you take HDFC Bank or ICICI or Axis, Kotak, so all of them are doing very well. On the public sector side, SBI is doing very well, and all small banks are also doing very well. Bank of Baroda and all those things. See, the most important aspect here is why there is a sudden growth in the banking sector, banking and financial space also. It's all because of cloud and AI services only. See, if you look at ICSI, they have the best IT infrastructure. I'm really a big fan of it. So we really use them as part of the payment gateway today. So everything is online, right? And we also use that for all our software which we're developing. I take care of the state admission software. I do the admission for the entire state, Puducherry state we do, and I write the software. I had the software development team, and we really use clouds, and we, of course, started implementing AI also, but not in a big way. So there we also use the payment gateways. Now, you take any application, payment gateways are the need of the hour. Now, coming back to the banking space, see, you look at the year 2000, you would have seen, we have seen a lot of ATMs coming up. After 2003, 2004, people have stopped going to the banks. So everybody started thronging the ATMs. Okay, slowly then what happened is we have seen the digital payment, Bharat Pay and Paytm and all those concepts, right? Today, Google Pay is also very famous. So now, see, this is the era where, we are using the concept of, we are extensively using the concept of digital money. Now, what happens here is, in this scenario, people are trying to combine cloud as well as AI. Now, there is one application called Metaverse, okay, and that application has been already employed in leading banks like HSBC and JP Morgan. Okay, now they are planning to implement in all the banks. I just want to touch upon this. From here onwards, we will see. I'll take you to the security part. Now, what happens in the banking spaces? If you want to, what are we trying to do here is, we are really trying to use AI in a big way. Of course, all banks are now using clouds. So I don't want to talk about cloud right now. I'm talking about the AI part. Now, if you're considering the AI part, what they're trying to do is they're trying to take a gamified approach, right? They want to introduce avatars, okay, and then people will be sitting in the bank, and people will be sitting in their home, and they will be actually interacting with the bank. So this will work out well for especially for senior citizens, because they are used to human interaction. They go to the bank, and then they really want to they talk to the front office people, and then they like human interaction. Now we are trying to digitally reignite this human interaction through AI. Okay. So senior citizens sitting at home can speak to the bank, can digitally interact with them. Okay, maybe through avatars, and as I told you, it's going to be a gamified experience. Okay, now this is the current scenario. Okay, and then we are also going to bring in data visualization and information visualization also, sitting at our home. But the point here is, all is okay. Everything comes with some trade-off. The challenges of metaverse will be to buy VR and AR headsets. You should have that virtual reality and audio thing. That headsets you have to augmented reality, right, and video, virtual reality. You really require those headsets. So that comes with a small price. Nevertheless, if you want to have technology, you may have to spend some money. So that comes. But more than the cost of the headset, the cost, it's as I told you, it's a trade-off, right? You get human digital interactions, but at the cost of security. So we will be compromising on security, because a lot of things gets exposed. Okay, we will be trying when we digitally interact. Whatever the codes which we do, can be listened by the attackers. So as I told you, the interaction digitally, we want to reignite the interaction that we have done in the olden days, maybe 20 years back. Okay, we really all the state banks and other things. If you want to have a good banking experience, you should have your uncle and auntie working there. Otherwise, nobody will do a good service. When I used to say that, SBIs are all uncle auntie branch. So either you have to have somebody, your friend or some relatives working for those branches. So now this can be removed, and we can really give good services also using AI. But the point here is we are trying to compromise on the security. So that's a trade-off. So security is a big challenge thing, right? It's a very challenging task. Now, how are we going to address the security is a big question. So this is going to open up a lot of cyber crimes. So see, in today's world, what happens is there are two worlds. One is the cyber world, and the other one is the real world. So in real world, what happens is things are really established. You have good policing system, you have good legal systems. So as a result, things, any transaction which you do, whatever you do, you can do it in a very peaceful way, because you have a established policing and legal system, as I said. Okay, so things are settled down, okay, because for more than 40, 50 years, these legal systems are in place. And of course, they are doing a good job considering the population of the country. But the point here is, do we have such legal systems, such policing systems in a cyber world? That's a big question mark. We don't have such things. Okay, we don't because I feel all of you in this forum are mostly IT and computer science professors, and most of the time, maybe 50 to 60% of the time we spend online. We are in the cyber world. So today also I'm sitting in the cyber world, and we are interacting in the cyber world. It's not real time. I mean, it's not in the real world. And I say it's real time only, but it's not the real world, where I don't come to you physically and then I don't take a class using Blackboard. But here the question is 50 to 60%. And during Corona time, COVID time, 80% of the time we were hooked to the OTT platforms and Google Meets or Zoom or something like that. And then we spent most of the time in the cyber world. But the point here is we don't have good cyber laws. We don't have good mechanisms in place. Probably it will take some more time. So that is what Mr. Hari Prasad, can you mute yourself? Yeah, yeah. Hari Prasad, somebody is presenting. Manashekhar, yeah, yeah. So yeah. Okay, so yeah, now he's muted. Now the point here is, today's challenging issue is this one. So we not only have, AIs, we have AI. Through AI, we are able to create a smarter world. There is no doubt about that. Clouds really, they are coming very handy, and it's a really what they're helping us in all ways. They provide platform, they provide software, they provide infrastructure, they provide everything. Okay, at a much cheaper cost, right? Today I don't do the server administration because my entire data for the admission data is there at the cloud. And today also we have a college management system and a university management system for the entire state. All their data pertaining to colleges we maintain in a cloud, right? We have SLAs, and then the everything server administration and data part, how they're handling data, all those things the third party is taking care on behalf of me, right? I just have to do a subscription every year. I have to pay the money, and that's all. But having said so, A is nice because it is creating a smarter world. But it all comes with a price. That is the problem. So all these technologies are very good, and even the cloud is very good, but they're very vulnerable. Okay, so that's why security comes. Presumes a lot of importance. That's why today the hot topic is, on one side you have AI, one side you have those deep learning concepts, this machine learning concepts, and the cyber security is also taking a big place. Today, that's why we are establishing an university on cyber security. There are specialized in all states of the country. We have digital forensics, and we have security university. Okay, we are also planning to bring in, because already we are in a DIT program. So we are part of the Department of Information Technology, New Delhi. But now we also intend to start next year some courses on digital forensics and cyber security. And this is thing, current. Now the point here is what I'm trying to say is I'm trying to set the context. I want the audience, the participants sitting in this forum, to realize the importance of security. These AI and other things all creating a smart world. As I told you, like the example which I stated, metaverse in the banking paradigm, it's all nice, but only thing it comes with a price. That's the security. So we have to handle security. So what I will do is for the first half of the session, I'll be setting the context. I'll be introducing to you the cloud. I understand I'm the first speaker of this program. I know that's why there is a welcome address and other things. Am I correct, Jayanti ma'am? I'm the first speaker, right, for this post? Hemlata ma'am, are you there? Okay, any audience can unmute and tell me. Am I right? Is my understanding
Yes,
right?
sir.
Yeah,
Yes,
yeah.
sir.
So okay. In that case, I will introduce the cloud basics and other things, and I also showcase two of our recent works. Very recently, we have done works. We have addressed the security issues in cloud. I'll try to show. Okay, we have used blockchain and other cryptographic mechanisms also. In one work, we have used cryptography. Other thing, we have used blockchain. So those two works we will try to showcase. Okay, myself and one other professor we have done. So we will invite also. Okay, so the second part we will showcase that part, techniques where we have used, and it's also there in the net. Our paper is available in the net. At the end of the session, maybe I'll tell the paper name and other things. It's in John Wiley. The publication is John Wiley, 2022 only. So though you can go and read the paper. Anyway, we'll be explaining that work also. Okay. Now, having introduced the thing, subject, the context for a discussion, I will go with the natural flow of slides. Okay, I'll start presenting, and then we'll see that. We'll go slide by slide, and we'll try to have a discussion at the end. Okay, so give me some time. I will discuss. Okay, and if you have some queries, you can reserve it. Maybe at the end we can take. Okay. Is it fine?
Yes, sir.
Okay, I will start. I think the screen is visible now, ma'am.
No, not yet, sir.
Is it visible?
Yes. No, sir,
resume.
still it is not.
Yeah,
Now it's yes.
I'm trying to resume. Is it visible right now, right?
Yes.
Yeah, okay. So I'll start from the beginning. Okay. So in fact, these are all, the entire presentation is based on two research papers only. Okay, because since we do research in cloud security, we have worked on these papers also. That's first half, on two papers I am presenting. One is a paper called Cloud Security Issues and Challenges, a survey by Ashish Singh and Khalid Chatterjee. Okay, it has appeared in Journal of Network and Computer Applications. The other paper is Cloud Computing Security Issues and Challenges by Quero. Okay, it is in the International Journal of Computer Networks. So these two papers are the fundamental pivot, for this discussion. So I'll share those papers also. You can read. Maybe I'll forward the email to Hemilata ma'am. You can collect. Okay, so never mind if certain parts of the presentation is not clear, you can refer to these two papers, you will understand. And the second half, our work, which we are going to showcase, if you don't understand, still our paper is available in the net, so you can see. Otherwise, I will share that paper also to your coordinator who is organizing this program. Now, see, this is the introduction slide. So I have told enough about cloud, right? So they are actually relatively new technologies only, okay? And today they are used in all business houses, in educational institutions, and everybody is using the the cloud services. Okay, so it's simple. You store data in remote data centers and be accessed through the net. That's all. So we don't have data centers. We don't have the headache of maintaining data centers. Okay. So this is the idea of cloud. So we don't spend huge investments, on hardware or software. So everything we pay and then use. So just like you construct a home theater, okay, for 25 lakhs, okay, and then you watch movie. Instead of that, you go to the mall and watch the same movie in just 500 rupees or 600 rupees. So you don't require. So you don't need to spend upfront. You need not spend anything. So that's the idea. Okay. So pay and use concept. That's all. So that's just like you are touring a place. Okay. You don't construct a house there, right? You pay the resort for 2 days. There you stay and then you come out. That's all. For that you don't construct a house or you don't buy a plot. So this is the cheapest thing. It's the economy wise, that's the cheapest thing. That's why we say that we eliminate the need for large investments in hardware or spending money or time on hardware. It's a simple concept where you pay and use. That's all. You can access any number of resources, whether it is hardware or software. You only pay for what you use. You don't require, to have a licensed Microsoft Office, MS Windows, or whatever it is. All those things you can rent it. So for how much hour you are using, you will pay. That's all. So utility services from data storage to computing. So it's not only for storage part, the hardware part, the software part, name it, anything of computing, you can do. Oh, 1 minute, yeah. So there are cloud models, right? So yeah. The purpose is very simple. The remote storage of data as well as the transportation over public arises security concerns. As I told you, you need a network. Okay, you need a network to actually actually access the cloud. So that's why. No, that's why the slide is there. Okay, so once the network comes into picture, then the security aspect comes into picture along with the network. Now, there are two types of cloud models. One is the service model and deployment model. First, we will see what is a service model, and then we will talk about the deployment model. Now, there are, say, everybody knows, right? So we have three models. One is the infrastructure as a service, okay, and then you have a platform as a service, and you have software as a service. Now, yeah. So infrastructure as a service, the cloud providers offer data storage and computing power service at pay per use. Okay, and see, this is only for this data storage infrastructure for storing the data, right? Most of many of us are going for IaaS, that is the infrastructure as a service. Now then, we have other thing as platform as a service. Okay, so here the programming environment itself is provided. An issue. And there is some
Please
noise.
mute everyone.
So please mute, no? Yeah. Yeah. So what happens here is platform as a services, the entire development environment is provided.
ஆடியோ
by the
ஆஃப்
cloud.
பண்ணல கம்மியா வச்சிருக்கேன்.
Okay. Okay. So this is what is platform as a service, and then we also provide software as a service. Applications are hosted by cloud service providers and made available to clients over a computer network. Okay, so these three are the most famous service models. One is IaaS, infrastructure as a service. Other one is platform as a service, and the third one is software as a service. Now, if you look at deployment models, you have private cloud, you have public cloud, and you have one more thing called the hybrid cloud also. And then you have also cloud, community cloud. We'll see one by one. See, private cloud is something like, it's very personal to the organization. So for example, ICICI Bank, if they have a cloud, it's very private. Only ICICI can access. Okay, others don't access it. Okay, so this is the thing. Private cloud. This is only deployed inside an organization. Okay, and then you have a public cloud. A public cloud is run and managed by the cloud service provider and the physical infrastructure that may be situated away from the location of the user or client. So public cloud means it's sharing only. So this cloud can be used by anybody. Okay, so something like multi-tenancy also, something like a flat system. Okay, somebody can stay in the ground floor, and the other person can stay in the first floor. The another person can stay in second floor. There will be something like a flat system. The public code is shared. Yeah. Hybrid cloud is a mixture of both public and private. So they are centrally managed. At the end, user perceives the whole as a single unit. So both hybrid. Hybrid means both public and private. So you are basically combining the advantages of private and public. So what has to be kept in a private mode, you will use private cloud. And certain things you can make it common. Okay, even if somebody steals that thing, steals that information, it doesn't matter. It's not going to affect us. So those portions you can put it in a public space. Basic idea here is cost only. Private clouds are very costly, expensive, and compared to public clouds. So community cloud is when people who share a common interest. Okay, so they have the common cloud service. Okay, this cloud can be characterized as a community service cloud. Okay, so for example, all computer science professionals can join together and have a common. All teachers, computer science teachers can join together, and we can have a community cloud. So all the information will be only pertaining to us. Okay, so these are the two famous models. One is the service model and the deployment model. Now, see, these are the challenges. See, once you have a cloud, So these challenges come into picture. One is the security part, the other one is the costing model, the charging model, and the service level agreement. And next question is what to migrate. And cloud interoperability is another big issue because there are different vendors, right? So somebody will be a member to one cloud, okay, and I may have to access data from some other cloud. Now, how are we going to do that? That's the cloud interoperability. Okay. Yeah. Security, cloud security refers to the processes, mechanisms, and services used to control the security, compliance, and other usage risks of cloud computing. So when we say the processes and mechanisms, we naturally talk about encryptions and other cryptographic mechanisms. So we mean only cryptographic mechanisms. So the same, say cryptography remains same, whether it is cloud or any other thing, network or whatever it is. We see network is also a part of cloud. The cryptography remains same. The idea of cryptography, like concepts like homomorphic encryption and ECC, they are widely used in cloud security, providing security. Here, the encryption mechanisms only. They use ECC, right? And then they start encrypting and decrypting things. So cloud security is broadly refers to measures undertaken to protect digital assets and data stored online via cloud service providers. Now, what is the costing model? This is also a challenge because there are a lot of service providers. Okay, so cloud consumers must consider the trade-offs among computation, communication, and integration. Okay, while migrating to the cloud can significantly reduce the infrastructure cost, it does raise the cost of data communication. That is the cost of transferring an organization's data to and from the public and community cloud, and the cost per unit of computing resource used is likely to be higher. Most of the time, the biggest challenge here is migrating is a big challenge. So most of the organizations and most of us, we have legacy data, right? We have been using in-house, we store, and then we have been used to this. The point here is, see, when you want to migrate to a cloud, we have a lot of hesitation. Okay. We cannot just like that, get into the cloud and start using it. The point here is, we have to migrate the existing data. Now that is very costly. Okay, that costing, people think twice because it is going to, they think it's an overhead, and they are also very doubtful. Okay, so long, my data is very private. It sits in my organization. The server room is in my organization. The rack server is within the organization, and I have an administrator. He takes care of them. So data is well protected, we feel. So all these questions come. So these things are only hampering the use of transition. When I say transition from the ordinary mode to cloud mode. Right? From the organization, we think twice because of cost is incurred for migrating the existing data of the legacy applications that are running in the organization. So that is the issue. Now, this problem is particularly prominent in the consumer uses the hybrid cloud deployment model that the organization's data is distributed among a number of public-private community clouds. This is still all the more very challenging because data gets distributed. Some part of data sits in a public cloud, and some part of data sits in a private cloud. So this is one more issue. Okay, this is one more issue. So on-demand computing makes sense only for CPU-intensive jobs. Now, charging model. Now, what happens is, the cloud service providers have also to do research in order to find a charging model that will provide a high profit and competitiveness between other CSPs. Now, the problem here is how to charge people. So you have seen, right? So BSNL is having one charging model. Airtel is having one charging model. Vodafone is having one charging model. Okay, they have two schemes like prepaid and postpaid. Okay, so these are all charging examples of charging models. Now the question here is, the question here is how the cloud service providers have to come out with a charging model, because the charging model is not all that easy, because there are a lot of cloud service providers in the market, and it has to be very competitive also. It has to be very competitive. Okay, it has to be very competitive. You have to take your competitors into account, and then you have to do a charging model. So that's what the challenge is. It is very similar to that postpaid, prepaid plans that are available with cell phone Mondays. Okay, it's similar to that. So I'm just giving you an analogy. There is something called the service level agreement. Okay, so this is SLAs are very important, because see, cloud service providers, they promise something. Okay, they say, right, they say that there is the server will be up, okay, 24/7. And one example of a service level agreement is, suppose if the server is down in another 15 minutes of time, you will be able to continue your business. So downtime is only 15 minutes. Okay, so whenever we write a software, when we give software development to third-party vendors, we specify the service level agreements. In one of my projects, I specified the downtime to be only 15 minutes. So in 15 minutes, they will have an alternate server, right? They will do the disk mirroring. Okay, whatever transactions we do, we actually do the mirroring part also. Okay, and then what happens is, if this server is down, so our business continues now with the other server. We have the mirror server, right? So this is called as fault tolerance also. Now in our computer science paradigm, we call this concept as fault tolerance. Okay, so so this is what we do, right? So this is one example of service level agreements. So there are other examples of service level agreements also. Okay, I'm talking only about the service, the server uptime and downtime. Okay, so these the first line, it just says, right, the clients have no way of controlling the sufficiency of the providing service, because everything is taken care of the cloud. So nothing is in our hands. Availability or reliability or performance, everything is in the third party. They do for us. We don't take care of availability. Neither we take care of reliability or performance. Availability is what I told you. The server should be available 24/7, 365 days. Even if it is down, okay, it can be down for 15 minutes. Because see, we see top business houses, they are very particular about business continuity. So that's very important. Otherwise, crores of money will be lost. So that is the idea. So the cloud service providers are responsible for all the thing, for all the above. When I say all the above, means the availability, reliability, and performance. So they actually put all these things in the thing, in the SLA. Everything forms, or everything is part of the SLA. Everything, all these agreements, they are all part of the SLA, and they guarantee everything. They guarantee 24/7 availability, reliability also, the efficiency, and security of data also they do. Okay, they are providing the security of data. But the security part, they also charge extra money also. So we also do SSL part, SSL security, all those things we pay. For enhanced security level, you have to pay more money. That's the thing. Okay. So this is part of the service level agreement. SLA is part of cloud. And now what to migrate? So you can just say, so it's a very long thing. Okay. In 2008, in one of the thing, this is the survey done. Okay. So IT management applications, they form 26.2% of the cloud usage. Collaborative applications, personal applications, business application is only 23%. Now the numbers should have changed. Applications development and deployment is 16%. Server capacity is 15%. Storage capacity is 15%. Okay. So what to migrate itself is a big question. Okay, why means see, all organizations are only having the security and privacy concerns in moving the data on the cloud. Okay, currently peripheral functions such as IT management and personal applications are the easiest IT systems to move. The peripheral functions are all ordinary data only. Okay, and personal applications are all okay because they don't have any business value. But organizations are conservative in implying IAS compared to SaaS because the software we develop and then we come out of it and then we run the software. But in infrastructure as a service, the entire data is in somebody's hand. So we have our own doubt whether this data will be reliable or not. Okay. This is partly because marginal functions are often outsourced to the cloud and core activities are kept in house. Okay. The survey also shows that in 3 years' time, 31% of the organization will move their storage capacity to the cloud. However, the number is still relatively low compared to collaborative applications all the time. So, okay, that doesn't matter. Okay, numbers are always there, but the point here is what we have to think is we have our own hesitation, because we don't want our critical data or our sensitive data to be in somebody's hands. That's the essence. Okay. Cloud interoperability is also very crucial. So here, what I do is, what I try to do here is, just a minute, okay? I'll just take some water. Okay. So see, today, as I told you, there are a number of cloud service providers, and the point here is, there is no standardization among these cloud service providers. That's the point. That's the biggest headache. Each one they take data and then they store it in their own way. Their formats are different. Of course, they may use XML and other web technologies. The technologies remain the same, but there is no as such common standard among the cloud service providers. That's really creating a headache. Okay, so that's a big headache for making this clouds interoperable. That is another challenge. So this itself is a big headache. So we have to achieve standardization. And of course, it's very difficult. They have to form a consortium and consensus should be there among all this. Plus, the idea is interoperability is, we want to have seamless flow of data across all clouds and between cloud and local applications. So that's the idea. So since we don't have standards across these cloud service providers, we have a phenomenon called the hazy cloud. Because hazy cloud is nothing clear. Nothing is clear. How data is stored in Amazon cloud, for example. Okay, in Microsoft cloud, how they are storing. So each one of them, they are not revealing. That's the problem. That's why we call it as this phenomenon as hazy cloud. So, but standardization appears to be a good solution to address the interoperability issue, but still there is lot to go because we have not achieved standardization. That is the issue. So this throws open a lot of research challenges also. So now coming back to our thing, there are, I start off like this, so there are a lot of challenges. Okay, security, costing model, charging model, SLA, and what to migrate, and cloud interoperability. Now, there might be these challenges, but now I'm going to, in this presentation, we are more concerned about the security challenge. Okay, so we will be addressing the security challenge. So that's the focus of our thing. Now, cloud security, as I told you, it refers to the processes and mechanisms. So that's all about the encryption only. How are you going to encrypt and decrypt things? Okay, the concept of security is remains same. But how are we going to apply in the cloud paradigm is a big challenge, right? You see, in the case of IoT, what we do is we use the same cryptography in Internet of Things. Since those Internet of Things, devices, IoT devices are resource constrained devices, their battery lifetime is very less. At the same time, their bandwidth is very low. Okay, and the speed is also very less. So in such a thing, what we do is we try to move in for ultralight cryptography. Ultralight cryptography in the sense the encryption and decryption algorithms are very simple. Okay, we go for simple mathematical functions. They're not that complex, right? We reduce the number of rounds, all those things, because we want to basically reduce the computational complexity. That's the idea. So once the computational complexity is reduced, we have to reduce. The intention here is to reduce the computational complexity because resources are very sparse in the case of these devices, IoT and other devices, right? Because cloud is also part of IoT. So I'm telling you, one example I'm telling you. So here, even though the cryptography, the concept of cryptography remains same, but there it takes a different color. The fundamental idea of cryptography remains the same, but slightly we change the color and we call it as ultralight cryptography, like Crescent, Cipher, all those algorithms. But the fundamental idea here is we use simple mathematical functions like XOR, AND, or something like this. Okay, like rotations, flipping the rotations, all those things we use. We don't use the number of rounds like those rounds that are used in tests and the AEs and other things. Okay, so this is here also we are going to use the same mechanisms, same security mechanisms. As I told you very recently, the blockchain is really very high, comes in handy in distributed systems. Right? I feel cloud is also a part of it. It's an advanced version of distributed systems. That's all. Because clouds are distributed only, right? They're across. So see, we sit in India, and all our data mostly will be residing in some states of the US, and you have some office in Delhi or Bangalore to whom we can connect. Okay, and they will be doing the services. I mean, the support for us. So what happens here is the cloud security problems. We have products and services. Okay, so as usual, in security we have two things. One is the threats and attacks. So here also we look into the threats and attacks. You will see that. See, these are all the different threats, right? Like identity threats, outsourcing risk, different service delivery receiving model, insecure interface and APIs, data loss and leakage, and service and then account hijacking. All those things are all available here because it's once again a distributed system. So because see, you might be offering web services and other thing, web services may sit in the cloud and you can use those web services. But the point is, when you want to use these web services, you require the use of APIs, application programming interfaces. But if the APIs are very weak, then that itself is a threat to the usage. So that's why. So the APIs are questionable. The strength of the API is questionable. How secure they are itself is a big problem. So there is an identity theft also. Somebody can steal my password, authentication mechanisms. Okay, somebody can do that, and then they can log in using my own identities. So that's a common problem. Like anywhere, you have this. And we have different service delivery receiving model. We don't understand which service delivery receiving model is very good in terms of security. That is also bit confusing. See, malicious insiders will be there, right? See, inside the organization, so somebody may steal our data. That is the problem. So because as I told you, we don't have control over the data. Our data will be sitting in US. So in US, somebody will be managing our server, and obviously he has to get to know our data, right? Because see, whatever it is, Gmail or Hotmail or whatever it is, somebody will be administering the server, the Gmail server and some other Hotmail server. Okay, they will get to see our emails. If they want, they can read. Okay, that's the idea. So malicious, if there is a malicious insider, then we can't do anything. So that's a quite common problem. Service and then account hijacking is also possible. Okay, somebody can hijack, somebody can spoof our account and they can log in and then they can start working. That's also there. So these are all some of the common threats, because as such, it's cloud may look very rosy. At first look, it may look very rosy, but it comes with some other set of problems which we don't really talk. Okay, but there are these issues are always there, and we have to be not little careful. We have to be very, very careful. Okay, these things are always there. Look at the attacks. You have the denial of service attack. The clouds necessitates the use of network. Now, how do you access a server? You require a network to access a server, right? So this denial of service is always there. Somebody can put queries, right? They can put a query in a loop, and the same you keep on querying your server for the same data. Okay, you put inside a loop. Okay, one is to 1 lakh times. That's all finished. There will be a lot of queries coming to your thing, and then finished. Your thing, your bandwidth will be full, and the server will not be in a position to reply to the other queries. That's a DOS attack is quite common, and service injection is also there, right? You have the concept of cross-site scripting, all those things. You can inject anything. Okay, phishing is also possible. Backdoor channel is there. Port scanning, all those things common attacks. Okay, man-in-the-middle attack is there. Okay, some you do not know, between you and the server, there will be somebody listening to the data. So you may think that nobody is there. Directly you are accessing the cloud. Okay, and then it's not between a one-to-one relation. Okay, when the data travels from US to India, okay, anybody can be in the middle and then they can listen to you. They can even manipulate the packet and then they can send. Then metadata spoofing is there and user to root. All these problems are there, attacks are there. These are all some of the common attacks. So I'm not discussing these attacks in detail because I just want to give an overview. Okay, if you want to read more attacks, I'll send that paper as I told you. Okay. So there are different security issues when it comes to different types of services. As I told you, there are 3 major services. I already told you that this infrastructure as a service, platform as a service, and SAS, software as a service. So all these 3 types of, service providers will have different sets of security problems. Some may be quite common for infrastructure as a service because in infrastructure as a service predominantly you store data, right? And platform as a service, you open up a lot of web services and other things also there. But XML is there. XML is handy, but still, as I told you, the APIs will be very weak. That's the problem. And then software service is also there. So the software as a service, it will have some common security issues. So each model is going to have its own security issues. That's what I'm trying to say. Now, IaaS in this one will have basic security because perimeter, firewall, load balancing is provided, right? So the cloud-based applications will need higher security levels at the host level. Okay, because other things we can do, right? We can give firewalls, we can do load balancing, or suppose if the server is overloaded, you can migrate the data to another server. All those things can be done in order to avoid a server crash. Right. So, but at the host level also we require higher security levels. So that they have to do, because we can't do anything else because they do the hosting part. So they have to. The service provider has to increase the level of security. So we, apart from this basic firewalls and load balancing, perimeter firewalls, they have to think about newer security mechanisms because the entire thing is now you can access a server only through network. So what network security, whatever you have. Security issues with network also comes up. Okay, your routing tables can be hacked. All those things, everything is possible. So all this, in general, the network security issues remains the same. In PaaS, platform as a service, the attention in security for PaaS should be given to the protection of virtual machines against trustless attacks using cloud malware. Okay, see. In PaaS, virtualization is a big issue, right? So what happens here is, just come. So you read the second line also, the preservation of integrity, all those things, integrity of applications and applying proper properly authentication checks during the transfer data across any type of networks. So I will just give you some examples of this VM. Okay, just a minute. Yeah. So in the case of the case of virtualization security, you have different security issues like VM's image management itself is a big issue. So a VM image management system is required. So one of the security solutions is you have to develop virtual machine image management system. You have to have virtual managed image privacy and integrity. You have to manage. Another one is we have to have a virtual machine monitor also to see what is happening, right? So some of the mechanisms will be, there are a lot of mechanisms available in the literature like hypercheck, dehype, hyperlock, split, visor, and not and no hype. And then the other issue is network virtualization, where the effectiveness of network security devices in virtual network has to be monitored. So this is also there. And here, in network virtualization, as I told you, like common network problems comes, like packet sniffing and spoofing, all those things come. Okay, so issues in virtual machine is there. There are other issues in virtual machine, like malware injection is one issue in a virtual machine, and you have side channel attack is also very prevalent here. Okay, and there are a lot of issues, but these two things are very famous. One is the side channel attack, and another one is the malware injection. So all those things are also there, right? So you really require, in the case of virtualization, you require an intrusion prevention system also. It's also there. Because in PAS, there are a lot of virtual machines are going to run. So we have to monitor these virtual machines. Why? Somebody can take hold of the virtual machine, somebody can inject a malware, somebody can do side channel. All the things are possible. So multi-tenancy is also causing a great challenge, right? So multi-tenancy is a concept wherein the same copy is being shared by many people, right? So that is there. Multi-tenancy is another issue, okay, where there is data sharing is there. So these things are bound to happen. So you may have to develop some security mechanisms in terms of, as I told you, the VM monitor, all those things, intrusion prevention systems, all those things you may have to do. And software as a service, the web security remains the same. Like as I told you, XML is being used. XML is very handy. It's already secured. Okay, but that doesn't matter. But there are other issues like the web browser. You have to you have to use a web browser to access any server. So the web browser security remains the challenges remains the same. That is the real issue, right? The internet protocols, web services, web technologies are all those problems remains the same. That's what we try to say here, right? Because we don't access software as it is directly. We need a browser where we have to go through via a browser. At the same time, if you want to use a web service, you have to use an application program. APIs have to be used. Application program interface has to be used. So you may have to use this, already existing security mechanisms like secure software layers, all those things. If you want, you can also use a VPN to solve this issue. So software as a service, also the problems related to web browser, the web security remains the same. So security issues can be further divided into 8 categories in relations with services. So I've listed these 8 categories, right? So one is the data storage and computing. Within data storage and computing issue, you have the data storage issue. Okay, when you take the first issue, maybe I put or not data storage and computing. So there, each one itself is opens a new thing, right? If you look at the data storage and computing security, there is a data storage issue. You have untrusted computing. You have data and service availability, cryptography, cloud data recycling, malware. All those things are all part of data storage and computing. So in data storage and computing, these security issues you have. Okay, these concepts like cryptographies will be used. In the case of virtualization security issues, what happens is you have the VM image management. We may have to manage the images. You should have the virtual machine monitor. Okay, you should have the network virtualization. You have the mobility, have issues in virtual machine, and once again, the malware is also there. Okay, these are all the security issues relating to virtualization. And you have the internet and service related security issues. So in internet and service related issues, you have they see once you have the internet services, you have the internet protocols, right? All security issues related to internet protocols, web services, web technologies, they come into play. Okay, and these are all related to internet and services. Now, if you look at the network security, okay, network security means, as usual, the mobile platforms and circumference security comes into play. And if you look at access control, the issues like physical access, they can be divided. This access control issue can be divided into subcategories like physical access, your user credentials, and the entity authentication, the authorization, management of user identity, anonymization, wherein the privacy preservation is also an important aspect. Okay, so how you anonymize, anonymization is how you carry out on those things. And if you look at software security, as usual, there are two things. One is the user front end and the platform and frameworks. As such, platform and frameworks, they pose some security threats. Yeah, those also remains the same. And the user front end, the user interface, they also, they may be, sometimes they may also be vulnerable. So these two things you may have to address in under software security. Under trust management, the same thing like reputation, anonymization, human aspect is also there because you may have insider threats. Okay, and cloud to cloud trust. So between two cloud vendors, how to trust. If you move data, if you are in one cloud and you want to access data from some other cloud. So what is the trust factor between these two clouds? All these things comes into picture. The compliance and legal aspects, all this, as I told you, the legal problems are always there. Okay, still they are not settled in the case of cloud. Unlike the real world legal system, we don't have a proper legal system. We don't have proper forensics, proper acts and laws have not been enacted properly, and there is governance is also a big problem. Incorrect resource usage metering is also a big problem. You may be consuming less resources, but when you see the bill, the charge is not correlating. The charge is very high. So you may be using less resource but paying more. Now, in that case, whom to go? Whom should you go? So all these things, all this compliance and legal aspects are they still remain the same, and then they pose a big challenge. So all these things we have, this is under data storage. I've spoken already. This is under virtualization, and this is the under internet services. I must have moved while discussing, but I have not moved. Okay. Tiffany, are you here?
Yes, sir. Yes,
Yeah,
sir.
yeah. Yeah. You just give me some 2 minutes, okay? Uh, I'll be back.
Present பண்றேன் சார்.
Okay. So yeah, see, we will try to see, and we have solved two security issues in cloud. We will try to now showcase those two things. Okay. So this is the mobile application security one we are dealing. So I don't want to talk about theoretically, okay, these solutions. No, I'll just try to give you one of our solution for this problem. Two solutions we have proposed. We show. Padri, you can present. No? You can put your slides. Put that slide.
Okay, sir. Okay, I'll be sharing.
You share the slide. We show our work instead of spending more time on the basics. We will try to. I think we have accept the context. No?
So is it visible, sir?
Yeah, it's visible. Yeah, you just go ahead. So you see, you just try to focus on the basics. You nicely explain the work. Okay, the blockchain, how we have used all those things. Okay.
Yes.
Let's start presenting. Yeah.
So good evening to everyone here.
Yeah, good evening, sir. You can proceed.
So today I am going to present the session on my name is the Pajani. So I am doing my research in Pondicherry Technological University under the guidance of Dr. Jairaj sir, professor and head, Department of Computer Science Engineering. So I am going to explain the topic of the how my research is taking place, how it is working. So my thesis studies the heterogeneous security model for the distinct cloud resources with various services and the user access level. Here the outline, we are going to speak about the reviews and then the problem statement and the objectives and what are the proposed methods for our research. The one is the authentication, what type of the authentication based upon the access level, that is the compliant access level control scheme we are implemented, and then we are going to access the authenticated level of services. The next one is the privacy preserving with the security level. So first scheme is we implemented a compliant access control scheme for authentication level. Secondly, we implemented a privacy preserving as well as the security level with the dense service intervals. And then third one, we created a framework, block-based authentication framework for service level security, decentralized cloud resources for accessing the decentralized cloud resources. So here, first of all, we can see what is meant by heterogeneous network. It is a network connecting the computers and other devices with a different operating system and with the protocols. That is why it is called as a heterogeneous network. So the security model means it is a framework in which the security policy is developed. Here, the development of the security policy is geared to particular settings or instance of a policy. For example, security policy means based upon the authentication or built within the confines of security model. It is a different in nature from similar type. So the cloud computing is a delivery of different services through the internet. So or we can say cloud computing is the on-demand with the remotely access services, we can see in different words. So these resources include the tools and applications like data storage, servers, databases, networking and software, etc. So here our work explains about that the cloud platform offers the resources like services and infrastructure based that support for heterogeneous application users. Here the user density and service delegation are the inevitable because of the user position and time, mainly that. So because of that, the robust service delegation model must satisfy the security demands of the users and their resources. So that is introduced by Zhu et al. And the next one is the access control and privacy preserving are the fundamental security measures offered by the cloud for its heterogeneous users. Even though the access control in the cloud relies on a user attributes and behavior for preventing adversary resource breaches, here they determine their previous behavior as well as the current authentication measures verified by the cloud service provider introduced by the Q et al. And similarly, the multi-user level, here the user privacy and the anonymity level retirement are the crucial processes in the administering with high-level cloud security. Here the multi-server and multi-user environments such as the cloud domain security and the user anonymity preserving are complex. It is due to the infrastructure, service density and the resource management functions and also the large scale it is introduced by the Munch et al. Here, therefore, the authentication, authorization, or auditing based upon that the auditing based on measures of the admin to the user. Here, counter the data privacy is ensured based on the integrity verification as well as the encryption with the meta features. The data privacy, user and data privacy preserving methods are jointly used in these. Introduced by the Tian et al. Mainly, he introduced the user and data privacy preserving, and the next author they introduced the service level agreement level in their work. They propose that whenever the resources, if they are accessing what are the services, how the better service to the user without any security issues. That is one important thing, how to provide, how to protect your informations. So based upon the previous request and related information to give the service at a need time. So that is why they're going to focus towards the service level agreement is the method they propose and provide the data with this.
Ajay,
Yes.
can we directly go to the blockchain usage? No? Why you should? Can you go to the blockchain and then explain?
Okay, sir. I'll be.
That we can directly go. So that work will be, instead of, I have done spoken enough for theoretical part. You can go and explain that work. Go, no? Go below.
So this,
First we'll
this is
explain
the-
the blockchain.
So blockchain, here we are using the
No,
complete.
I think the slides are not moving. Why don't you run through that slide?
So now
Go
it
to
is.
the blockchain part. Yeah, it's not moving. You have
It is
to
moving.
share, no?
It is moving or not?
No, it's not moving. For others, it's moving. No. Okay. What about for others? Is it moving, madam?
No, sir.
No, it's not moving.
So I think it may be network issue maybe.
No, not work. Yeah, you go. No, you just say. See, you say present, or you send me the slide. I will present.
Now it is.
Is the thing visible, madam?
Now it's visible.
No.
No, sir.
Hey, there is something. You see, after the hand, there is something called presentation. No, you just have to press that. Choose the window. Okay, you email me the slides. No, I will present others. I can talk. Ajay, otherwise you email, no?
Sir, now it's visible, sir.
Yeah, now it's presenting. Yeah, now it's visible. Very good day. Okay,
It's okay.
this paper, yeah, this you explain. Straight away you can explain the work. You work you please explain in a very simple way so that people
Okay, sir.
understand. I want the audience to understand. Yeah. So,
So
what
here-
research innovation we have done, we will discuss.
So this is the work we done for the authentication framework. So here we created the authentication plus privacy preserving in our the services for accessing the cloud resources. So we know the blockchain. Blockchain is a cryptographic function. It is used to secure the digitally we can maintain the immutable ledgers of records. So it is also the growing list of records called blocks. We can say it is linked using the cryptographic block contains the cryptographic hash of previous blocks with the timestamp as well as the transaction of data by completely with the keeping the distributed ledger. So whenever it modifies or updating the data, the transaction details such as records and information may be included in our ledgers. So that is the blockchain. So here the blockchain here we are using the transaction here immutable ledgers and also the decentralized peers we are going to connect and also the encryption process also we are doing in our mechanism. So mainly the transaction in the meaning is suppose whenever if you're going for transaction it is going to be actually the decision and act based upon the proof of history we are going to provide as a prevents and then so the immutable in the means here the existing databases, we are going to once the return to the chain, and then the blocks can be changed whenever they extremely so it is going to be rework of all subsequent blocks. It is going to be included in the immutable ledger of records. So
Pajani, why don't you press the from current slide no, so that we can see a bigger version of the slide.
yeah, yes.
Press
Sorry.
Some basics
Yes,
of,
sir. Presentation is not
ma'am.
Not moving, huh?
moving and it's not in proper, I think so, sir. Just to check.
I'll be connecting. So here, our work is this.
No, you run. No, you run. No, you run. No. See, you put the from current slide. You run here. Yeah. No. See, you run now so that you make the screen bigger.
Now it's visible or no?
No. See, the slides are. Suggest you send the slide. No, I'll make the presentation. You send the slide. No, Pajani. Yeah. You send.
Okay, I'll be forwarding, sir.
Immediately you send to G Zera that video.
So I forwarded to you, sir.
Which email? HOD email or G Zera's email?
G Jairam.
Yeah, it's received. Just wait. Yeah. I think now the screen is visible now, ma'am.
Yes, sir.
Yeah, you can start presenting now. Pajani, are you there?
Yes, sir. I'm here, sir.
Yeah, screen is there. No, you see the screen.
Yeah, see what happened. Something. See. Yeah, now it's okay. You can proceed, sir.
Yeah, proceed. Yeah. Hello?
Yes, sir. I'll be proceeding, sir.
Yeah.
Here, the primary objective of this to improve the safety of service level cloud resources. That is why to develop the reducible block-based authentication framework. Here, the cloud data is used as the foundation for the examination of security at every level of the services. Here, the service receives from the cloud resource and also monitors the security at the service level at various intervals. So, from the architecture, so the primary objective of this to shorten this session and also the cloud service lifetime across the multiple cloud resources. That is the main objective. So perhaps the new user and the session attributes have already been verified and accepted for use in key authentication and cloud service suggestions. Here, this poses a threat to the success of the operation. It is also possible to store copies of cloud resource as a service in already identified session. Then the accessing and sharing multiple resources also occurs the asynchronous security based on traditional authentication in the architecture. So the insecure authentication mechanism and service session grant also access to the activity of the cloud-based resources. Here the cloud session, here it explains the blockchain, group of the chains. It is going to be independently given for service as well as for the request as well as for the access level as well as for this storage, and then it is going to provide here the independent blocks of chains, ledger of information we can say. So the session based upon the request response it will be maintained, and then based upon the ledger of the request response, and based upon the access will be provided n number of blocks of the access services will be based upon the authenticated the request response. It will provide the access level, and also it is also going to provide the services. So based upon this the response with the access as well as from that it is providing the various services to the end level. So how it is going to provide? So based upon the user attributes such as the ID and email address, it will verify the credentials of the users, and it controls the similarity with the authentication and provide the service distributions with the variable based upon that accessing and sharing the multiple resources.
You want to explain this?
Yeah, yes,
Okay.
yes.
I think you can just mention what it is, that's enough. They cannot understand. It's very difficult in this session to come up with this. Maybe you can explain this part. Generation and things.
Generation.
Yeah. So how the key is generated between the end
so
user?
Here we are using the key generation process. I think we know about that in the RSA algorithm how we are doing the key generation process. Similarly, we are using the process of key generation. So we know the random number of that u and v variables, and then we are computing the n values based upon the random variables. We are computing that u and v. And then based upon the Euler-Gaussian functions, we are computing the function of the phi of n. And then we are randomly selecting the variable e as a random variable within the ranges of the phi of n. And then the relative values of the relative prime number of the d we are finding based upon the e. So with the relevant with the mod function of 1, we have information. We are going to create a n number of sessions based upon the user will be in the access level. So we want to generate a n number of keys. So here we are using d power key. So then n number of key will be generated based upon the sessions. So here based upon that we are sharing the service level agreement. So it is the message authenticated the hashed function we are sharing towards the authenticated service towards the provider, user towards the provider with the session agreement key with the session level of access of the user. And based upon that, we are verifying the authentication services with the timestamp. There is a change in the timestamp, or whether there is a without the change in the timestamp. So whenever the user density increases, the change in the timestamp will be whenever will be there. So to reduce the session level, we are going for improving the verification level access. We are using the whether the sessions are available in the line, then based upon that we are providing the access services towards the user level. So that is why we are generating the a power k is the key. So based upon that, the n number of keys we are verifying based upon the services, based upon the sharing level access with the shared keys. So here the agreements will be based upon that agreement will be taking place. This integer shows the session based agreement, and then based upon the available session based upon the attributes of the user, how the user attributes, what type of access he is taking, and what type of event he is accessing, and based upon the authentication it is providing the agreement level. So this is the ledger of records of information based upon the session as well as the attributes. We are going to generate a service distribution towards the end level. So the F is represent it is the ledger of identification of information for the records for the based upon the session and then associated attributes. So mainly here we are focusing towards the records based upon the session to improve the service level agreement as well as the based upon the service level distribution here. Here the ledger will be the identifies the importance about the recording sessions and also the associated attributes based upon the distribution metrics and also the flexibility level, and it improves the service level agreement based upon the additional agreements and depending on the flexibility estimates based upon the different training instances.
Okay, so this performance they don't require.
The results shows that here the framework based upon that applet modulator we simulated these things. Here the number of users is 108 service provider we are used for creating this cloud scenario, and here we are taking the 750 GB of the multimedia data and also the 160 bit of the blocks of the key generator, and then using the conventional elliptical cryptography used for the authentication encryption level. Here the service is defined as a block, the server is defined with the blockchain, and then it operates with the regular interval 60 seconds per session. Here the metrics, the service distribution ratio, false rate, session uptime and delay, and then the comparative analysis the use with the here the previously used the schemes, and then we are comparing with our the proposed approaches. Seamless here the secure anonymous authentication scheme, then the lightweight multi-factor authentication and authorization scheme. So with the IoT based authentication scheme, we are comparing with the existing the proposed scheme. Here, even though we implemented the present service distribution ratio for users and their probabilities, here it maximizes the agreements level and also with the based upon the user session and with the service distribution level. And here it ensures the better distribution data based upon the related keys, and also accessing the sharing probability also increases. It also improves the maximizing the adaptive level. Then if you come across the false rate level, so the proposed framework achieves less false rate by reducing the accessible level of the authentication instances and also the conditions satisfied, and the agreement key established also secures the individual level and shares the intervals based upon the timestamp and also maximize the security level. So then the agreement level is utilized based upon the distributed shared keys. So the availability is high. In that case, the RC is verified with the distributed shared keys with the authenticated user level and also the unstable users in the communication process. Then it creates the secure end-to-end manner, the maximizing the success rate, and also the without deviating, it is providing the service level agreement to share the sharing the process. When the session uptime, the analysis of the service uptime will be under different users based upon the service level agreement. So the proposed framework provides the maximum the service level for the different users satisfying the requirements, and also the validate with the based upon the authenticated credential levels with the session value over the different time instance, and also the proposed the balances with the with all values of the user and the service provider, and also based upon the session time is retained, and also it achieve the high session up time for the different level of service levels. And if you compare with the service delay, so the analysis, the keying distributions and the authentication process is performed under the limited time requirements. Here, based upon the service and the authentication and the key, the increases in this case the consecutive level of the independent shared key is established, and also the new D is reckoned without additional time. Based upon that, there is no deviation. The process, the disconnection are prevented, and it achieves the high service augmentation will be increased without delay less. Here, the comparative analysis for users and also with the service provider we are providing. Here, the distribution ratio, if you compare with the previous analysis, our is achieves the very high, and the false state, if we compare with that one, it achieves a very less in the compare with the previous analysis, seamless, and then the lightweight method of authentication schemes. Then uptime for accessing the resources that it is high for compare with the previous analysis schemes, and then the service delay is also the very good in the compare with the previous analysis. The probability for analysis also the very comparatively very high, and with all the service delay and everything. Here this paper is also improve the session uptime and distribution of cloud user services, and also the analyze for different user based upon the stability and flexibility level offered by the cloud resources. Here it is authenticated using the attribute dependent keys. So here based on learning recommendation, we are using the learning recommendation based attribute dependent keys. We are distributing towards accessing the services. This learning is performed based on the previous session uptime and blockchain inputs, and also reduces the false state. The session authentication scheme also modify based upon the recommendation, and also the flexibility factor in maximizing the service level, security level. The proposed framework achieves the 11.39 high distribution ratio, and also 12.6% high uptime, 6.66% of less false, and also the 14.74% of less service delay for different users.
Okay, I think
that is why we are recommending.
We can stop here now.
Yeah, yes, sir, we can.
Yeah, we can. I think go back to the other slides, and I will present. So I do not know whether the audience have understood the use of blockchain. You have to use blockchain for one server, that's all. And then see, you can use OpNet cloud simulators, and then you can do this work. So some or other, I do not know. I think I'll show you the paper. You can just type my name and see, right? In Google, this paper comes. You go through the paper. Okay, we are just showcasing the work. Maybe we can go back to the basics, and once again we'll continue the other slides where we left.
There is a various tools are there. Hyperledger and Ethereum tool is there. Using that also we can use the real accessibility of the service, the security level we can implement as a ledger of informations.
You can tell them some few open source tools that's available so that they can also work and see.
So we can use this Ethereum, we can use as that one, and then Bitcoin only for transaction level. It is initially they implemented for accessing the ledger of distributed services. We can use Ethereum as the Ethereum we can use, or otherwise we can use Hyperledger. With Linux as the operating system we can use, and then we can access that is a very open source, that one, Hyperledger. That is a very good tool.
So we will. So I'll continue with the things. I'll try to give some more solutions to security issues. Okay, thank you, Pajani. Okay, I will start this work. We'll start presenting. Madam Hemalata, we have some more time.
Yes, sir. Yes, sir.
So I will give the solution part.
Yeah, finally, yeah, summarize.
One part we gave, but I do not know how far this reached people. But still, they can refer the paper.
Yes,
So
sir.
just I just want, since they are teachers, I just want to showcase some work, some tools, so they can.
Yes, sir.
Okay, I'll try to.
Okay, sir.
I'll try to do that. Is the screen visible? No?
Yes, sir, visible, sir.
Yeah. See, let us discuss the solutions to security issues. So, see, as I told you, the security issues are there. We have mechanisms like, authentication and the same key distribution, the same cryptographic mechanisms like encryption mechanisms are used. So those things remain the same. Okay, you cannot say that in cloud, you have some different security concepts. No, nothing like that. Same fundamental security concepts will apply here. They still hold good in the cloud paradigm. Okay, so now the latest thing is, you can work on blockchains, and then we can we showcase some work on blockchain. So you can read the paper in depth. Okay, that paper which we have published, you can see. It's available in the Google thing. Once you search in Google, you will read that. I just wanted to show you some experimental part also. There is still scope, still we can improve this work. It's only a preliminary work. Now, see, coming back to our thing, I told you there are so many security issues in cloud. So everywhere you have a security issue in the network itself, inside the cloud also it's possible. Attacks are possible. Virtualization in the virtual machine also it is possible. Okay, so in the data storage part also it is possible. Once you let's say if you offer some platforms, software platforms, okay, like web services or whatever it is, any platform that we try to access the cloud, there also these software are prone to security attacks and threats. So that means, in my opinion, the entire concept of clouds are, they are vulnerable at all points. That's what I'm trying to say. Everywhere, they are vulnerable. Be it in the network part, be it in the storage part, or be it in the software part, be it in the hardware part. Anything for that matter, they're very, very vulnerable. And not only they're vulnerable, the other aspects are also there. See, the support for support mechanisms, for maintaining the cloud itself is a big issue. So I'll tell you one real-time example. Some 2 years back, when our server got hacked, the entire admission data was there because the payments which we receive for MBBS and other courses, it's very huge. In terms of lakhs, 25 lakhs or 30 lakhs, especially the NRI students, they pay in terms of crores, they pay at least 85 lakhs, and sometimes these fellows pay 1.2 crores, something like that. To that extent, we collect money. Some or other, the hackers, they have found that, some or other, they have scanners, they have some provisions to find out, in which cloud, a lot of money transactions are going on. So some or other, we got our server down. Okay, it was actually hacked by the attackers, and we have approached the cybercrime, and the cybercrime police, they were unable to trace. They are saying it is from some South African country. Some they are trying to trace and show this is the same IP. Some they're tracing the IP, but they are not giving the solution. How to stop. And we are also approaching the cloud service provider, but unfortunately, the cloud service provider is in the US. So our day is their night, and our night is their day. So we are having a horrifying experience. Other one point I would like to say is important point is I cannot contact anybody. So here in the case of cloud paradigm, you have to raise tickets only. So you do not know to whom you are speaking. You simply have to raise tickets and say the cloud is down. Okay, the server is down. I'm having these issues. Then see, once the ticket is raised, okay, the fellow sitting on the other end will give you some solution. So you may have to work on that. So these are all some of the issues which we face. So see, still the server was not up. So what we have to do is we have to migrate to another server. All the data we migrated, and that customer support, we had the office in Delhi. Okay, but still we know that this is the back end, the server, our cloud is in some American state. That much is there, but at least we are able to hear, if there is a payment issue, if there is an issue, we are able to talk to the person. An Indian who tries to, you get yourself connected to them, and they will at least talk to you. Very recently, there are some issues in cloud also, usage of cloud. So we were using the old version of PHP. We are using the coordinator framework. So what happened was the coordinator framework version, the old version is not supported, because 3 years back we have developed software, and the software is residing in the cloud, and that is working fine. Now we wanted to develop an application for the government revenue department, and we developed and we hosted in the web server. It is not working because they're saying that you have to use the latest coordinator framework, because the latest framework is better. Older versions are more prone to security attacks. Then the solution was we created one folder, okay, and we through that folder we asked the service provider to install the old version of PHP, and then we started working. So these are all some issues in handling cloud, right? We see whether it is software, the versioning problem is there, and the attacks problems are there. When you're doing a lot of financial transactions, there are problems. Even ICICI server got attacked. Even though the ICICI server, one server is in the submarine. Okay, it is underground in sea through optical networks, through acoustics, underwater acoustics, networks and optical networks. They're able to deliver the service. But still, there was a downtime for 2-3 hours. There was a downtime. Okay, and recently in Hyderabad there was floods. Okay, they had one more main operating server in Hyderabad, and that also got attacked. So the point here is, we don't say that cloud is free from all these issues. It's not all that smooth. Once you are an user of cloud, you have to face these issues. Okay, there are solutions. Okay, and then day by day, we are trying to improve security mechanisms. We are addressing the security issues and other issues also in cloud. As I told you, the software versioning issues. One example I told you. So there are issues now. See, what is the solution for the security issues? I just told you right from software to hardware. Okay, everywhere you have a security issue. The network also you have the virtualization part. Everywhere we have the security issue. Now, what is the solution to this security issue? So one is, as I told you, you have to find the right CSP. As I told you, we migrated from one service provider to the other service provider. So we feel that the service provider is very good right now. So I told you, the office is in Delhi. So we migrated from that server, American server, to this server, and this server is fine for us. For the last 2.5 years, we don't have any issue. Other one is use of data encryption. So you have to use the correct encryption mechanisms. Like, sometimes we may have to manipulate the ciphertext. So in that case, we may have to go in for homomorphic encryption. And ECC is lightweight, and we use ECC. They at the same time, the number of bits used in ECC is very less, but the security level obtained is high. So ECC, because the polynomials and the prime numbers, the prime fields, if you're able to identify, it should work. The other one is the recovery services should be proper. The recovery services, okay, that means backups should occur frequently. And then the other one is a systematic knowledge of data flow. So how we should understand, how data is stored, how it is being retrieved. All those things is the systematic knowledge. And the other one is the organizational infrastructure. So we'll see one by one. These are all the solutions. These are all the concluding part of the presentation. See, this is what I told you. There are various security and management schemes, right? So see, first we were in one service provider who was very cheap. I don't want to name, but now we are using with fresh hosting. The service provider, the cloud service provider, is fresh hosting. So fresh hosting, they are doing a very good job. In fact, they have two clouds. Okay, we are operating on 2 clouds, but both the clouds are very good. So the best thing is, you have to identify the right service provider. As I told you, in terms of support, in terms of security, all those things. But security comes in additional charge, but it's okay. They try to charge you like an SSL package. If you take, they charge you some 25,000 extra, but you have to take. There's no other option. So that's okay. So as long as your whatever the data and other software that is running in the server is safe, we don't mind spending this. Okay. So in order to find the best solutions, users have to choose a provider that the scheme matches their needs. In addition, it is fundamental to choose a CSP that is legitimate, well established in the market. That is very important. Like, Amazon, we even spoke to Amazon Cloud and Microsoft, but they're slightly expensive. Okay, they're slightly expensive, but point is, their security mechanisms, other things are very, very good. And the proven mechanisms they have. And they have experience, and they should have the recognition of the IT community. As I told you, I have talking about Google Cloud is also good, Amazon is also good, Microsoft is also good. But we are only with a local thing, but still they do very well. But meeting the above suggestions, it is more likely that the users' data are well protected. So what we are trying to say here through the slide, if you choose the right cloud service provider, most of your problems gets addressed. So that's the essence. Maybe you have to talk to the person. But if you are willing to spend money, you go to this branch like Amazon and Google or Microsoft. Not a problem. Use of data encryption. So obviously, popular schemes, right now in clouds, elliptic curve encryption schemes are useful. As compared to RSA, as I told you, the computation complexity is less. And at the same time, in ECC, you get better level of security. The key size is also very less. For lesser key size, once the key size is less, the computation complexity comes down. But at the same time, you have better security. If you choose the appropriate prime fields. The other one is the homomorphic encryption. So homomorphic encryption is okay. It's just like, you can manipulate you can apply security mechanisms, or you can do any operations. You can manipulate the ciphertext itself. The encrypted data itself you can manipulate. But that will convert it into, once you decipher, it will convert it into proper form. So sometimes you don't want to you don't want to apply the encryption, convert the ciphertext to plain text, and then increase the level of security. You want directly, you don't want anybody to see what is there inside. You can directly do the manipulation in the ciphertext. That's what is homomorphic encryption. So they directly, the ciphertext itself you can manipulate. Okay, ciphertext is something like encrypted text we can do. This is what this slide says. Homomorphic encryption is a form of encryption that allows computation on ciphertext, generating an encrypted result, which when decrypted matches the result of the operations as if they have been performed on the plain text. The purpose of homomorphic encryption is to allow computation on encrypted data. They provide better security. That's what. The ECC is, as I told you, it's a public key cryptography based on algebraic structure of elliptic curves over finite fields. ECC requires, I told you, smaller keys when compared to non-ECC cryptography, like RSA or other things also, based on plain Galileo keys. They provide equivalent security, and sometimes the level of security is also increased if you choose the appropriate prime field. That is very important. The recovery services is also very important, right? So even though sometimes our cloud server may get compromised, but the recovery, if you have good recovery service, you can always do that. So that is a backup only. Backup mechanism should be very nice. Users must be provided the ability to recover data in case of loss of manipulation. Frequent backup of data can offer that. So you should have a backup policy also for how long you can back up the data and keep it in the thing. But once again, if you frequently back up and if you store it in the cloud, it becomes very expensive. So what you have to do is from the backup from the cloud has to be moved to your magnetic tapes or whatever it is, your external drives. You can do that and then delete it, because you don't want to spend money, for the cloud provider you have to pay. So frequently, what you can do is you can move from the cloud to your devices. That's also possible. So this way, data can be recovered. They can enable users to continue their work just before the point the data was lost or tampered or destroyed. So basically, rollback. So At one point, maybe there is a crash. So we until that point, we're able to recover and then do that. That's the concept of fault tolerance. So they do disk mirroring. Okay, all the cloud fellows, they do the disk mirroring. Okay, and that comes as I told you in the presentation, that comes as part of the SLA also. So in whatever thing we do when we use cloud, the SLA is very clear. Okay, the downtime should be mentioned, and then the uptime should be mentioned. So in how many minutes it should be data recovery should happen. So see, at the end of the day, the business continuity is very, very important. So if you have a good recovery service, these security threats, even though we have threats, if our server crashes, still we can manage. In systematic knowledge of data flow, this is very, very essential. Cloud service providers should have a scheme that offers them the capability of knowing what the data is stored and what updates are made in the cloud. Thus, there will be a complete analysis of data. Now, problem here is, quite often as an end user, we do not know what is happening inside the cloud. It's just like a black box. Something happens in the back end. But as an end user, as a user of cloud, if you're able to have the systematic, if you're able to get the knowledge of data flow, how data goes from the flow, data flow means just like the workflow. Okay, when the data from the client, how it, when it reaches a server, how it is stored, whether it is stored in the encrypted form, what type of encryption mechanisms are available. All those things, if we have a good knowledge, then it will help us. Okay, it will help us a lot. The recovery, the solution part is becomes easy. Okay, so we should, it's our responsibility as an users of cloud to know how data is stored, what encryption mechanisms are available. What type of encryption mechanism they're using, all those things, what type of backup they are doing. Okay, all those things you should know. Better organization infrastructures. So organizations have to have hardware coming from large and recognized companies in the area. Okay, it is also necessary to have specialized software providing authorization, authentication, encryption, backup, etc. As if to the hardware, trustworthy providers should be chosen. So once again, what we do is we are looking at the brand. The reputation of the thing is very important. You cannot choosing the CSP is very important. At the same time, you should have a good software, which takes care of this authentication part, the authorization part, the encryption part, backup part, all those things you should have. Maybe you should have at our end also we should have. Then we should take reports and see, just like, on olden days, we were managing the servers, we had reports. Okay, and then we used to manage the server. The reporting part we used to take reports and we used to go through. What's happening, who are the users who are quite frequently using. We used to study the traffic and all those things we used to do. Same way, at our end, we should have all this specialized software to manage this authorization part, authentication part, and encryption backup part. That's also essential. So conclusion, cloud technology nowadays offers a great variety of services that appeal from single user to big corporations. They all take advantage of new benefits provided by these services, but one must be careful taking into consideration the consequent security risks while using these technologies. There are high costs, but the security risks are in immediate relation with the advantages provided. So always remember that it's cloud is not all that rosy. Cloud may offer many benefits, but at the same time, there are some drawbacks also. So, but if we take care of these security lapses from our end, I think we should be able to manage. Still there is no other go. No, cloud is very cheaper. No, we are still using. Currently we are using clouds for storage. So with this, we come to the end of the presentation. I think over to Madam Hemalata.
Yes, sir. Yes, sir. Thank you so much, sir. Really, the session was very wonderful. From basic to the final research, you have explained excellently. I don't know how, there is no words to say thanks, simply saying thanks. Like that you have explained, sir. The another thing is I just want to record one important thing about Zaira sir here before the participants. Actually, I know Zaira sir for the past 12 to 13 years. Whenever I was thinking about Zaira's one important proverb will come to in my mind. யூஸ்வலாக நம்ம தமிழில் சொல்கிறேன் நிறை குடம் தழும்பாது அப்படின்னு. ஸோ தட் proverb is always suits to our Jairas sir. So very technical and very knowledgeable person, but he never show anywhere, very simple, humble, and whenever I called, he used to give a proper response, and he will do all the things in my life. So my hearty thanks to Jairas sir. Thank you so much, sir. I know your busy schedule. I know you're the position. In between, immediately you accept my invitation and you gave an excellent lecture. Hope all the audience just they enjoy the session and they got very fruitful information through the presentation, sir. Thank you so much, sir.
Thank you, ma'am. Thank you, participants. I will send some of the materials also. You can pass on
Yes,
to
sir. Yes, sir. Because we need. So the final day we are planning to conduct the quiz and
No,
other
no, no.
things.
Yeah, I'll
But,
send
yeah,
immediately.
I will send, yeah,
I'll send.
I will share everyone. So
Thank you.
thank you, participants. Your feedback link is shared in your chat box. And the another thing, 80% of attendance is required. So you have to attend all the day, and then only you will get the certificates and other things. Now the feedback link is shared in your chat box. You can fill it. Thanks a lot. Thank you, everyone.
Thank you.
Thank you, sir.
I'm leaving. Thank you, Hemlata.
Thank you, sir. Thank you,
Thank
sir.
you.